This video is on the geometric concept of points, lines, and planes. So in geometry, we have some undefined terms, and our undefined terms are terms or words that can only be expressed using the examples and descriptions. And we have three undefined terms in geometry, and those are point, line, and plane. And what we can do is we can take a minute to look at these in terms of our diagram that I have here. So a point is like point A, B, or C, denoted by this little dot. Little dot there, little dot there. And it's hard for you guys to see, but I have like a little pen tip that I'm kind of moving above that diagram. And that's a good description of a point, okay? And we always label points by just capital letters. We have a line. Here we have line M that goes through our plane. So that's a cursive letter. We have line L that's contained in the plane. Now the difference between L and M is L, notice how L is all solid versus M, which is dashed. That little dashed part means it went through the plane. And then we can also name our line by 2 points that are on the line. So we name that by points A and B. So line L can also be named by A and B, but we put a little line symbol above that. And then our plane. Our plane, sometimes planes are going to have a little cursive capital letter in the corner, and that's how we would name plane K. You can also name a plane by 3 letters, and I don't think you have to write the lettered plane, but A, B, C. 3 points that are contained in the plane. So again, our undefined terms. Point is a location, has neither shape nor size. So I might write that description of our undefined term down. A line, made up of no points, has no thickness or width, and there's exactly one line. There's exactly one line through any 2 points, so I would write that down. Okay, and then this talks about what I just talked about. Line M, we can write it as PQ or QP. It doesn't matter the order of the lettering. And then a plane is a flat surface made up of points that extend infinitely in all directions. There's exactly one plane through any 3 points. So that's an important concept. Okay. Oh, and here they talk about how to name it. We can name it as plane K, or we can name it as plane B, C, D. Naming any of the points in really any order. So I would make sure you have this in your notes. So our descriptions of our undefined terms. Okay, and then these postulates that I have just underlined. And we'll talk about what a postulate is a little bit later on. Okay, our first example. Use the figure to name each of the following. A line that containing point K. So I have a line that contains point K. There's so many ways I could name this. I could name this as A, the cursive letter that's sitting next to the line. I could name it as line JL. I could name it as line JK. I could name it as LJ. Okay, there's a bunch of different ways I can name that. I'm not going to list all of them. And then a plane containing point L. So a plane containing point L is plane B, or any 3 points that are not on the same line, or non-collinear points. So J, K, and L, see how they're all on line A? I need to pick 2 of those J, K, and then one, and it has to contain point M. Okay. Okay, is a plane, a point or a plane contained in each of the following? Or best describing, I should say, or modeled. A 10 by 12 patio. Well, that's going to be a plane. It's a flat surface. Think about, I'm sitting here at my kitchen table recording this lesson, so I think about my kitchen table for that. A button on a table. Okay, well, that is a point. Okay, I've talked a little bit about these terms. These are important terms. I would make sure you have everything written down. Collinear, points that are all on the same line. Coplanar, points that are all on the same plane. Two lines intersect at a point. Okay, they have point P as their intersection point. Two planes intersect in a line. Here I have line R that intersects both points, or both planes. So I think about this as, look at a corner of the room you're on. So one of the walls that's in front of you and one of the side walls, they intersect at a line. Versus if you have two pencils laying down on your desk, two pencils are going to intersect at a point. I would make sure you have all of this in your notes. Okay, postulates and axioms. I talked about this. I used the word postulate a little bit earlier. Postulates and axioms are statements that we can accept without a proof. One of the major concepts that we're going to be dealing with here in geometry is this concept of proofs. We're going to be proving theorems. And postulates and axioms we don't need to prove because either they're so obvious or it's like a one-step, two-step proof. Okay? So through any 2 points, there's exactly one line. And again, I would make sure you have these in your notes. Through any 3 non-collinear points, there is exactly one plane. And I talked a little bit about those. Now, theorems. Theorems are proven using these postulates, axioms, definitions are already proven theorems. So we're using previous proven concepts or definitions or these axioms to prove theorems. So a theorem that we have from this section, and we're not going to worry about proving it. We're going to get into we're going to start off easy on proofs in a few chapters. If 2 points lie in a plane, then the line containing them lies in the plane. Okay? And these are more of concepts that you need to understand about geometry. Okay, an example that involves these. How many planes appear in our figure? So we have this figure over to the right, and I want to know how many planes are in that figure. So let's look at this. Okay. Well, I have plane S that is very, very, very apparent to me. Okay. That's the one that I feel like is the most obvious one. Now there's another one. Remember, any 3 non-collinear points are going to make a plane. Look at this plane here. ABCD. Look at it like it's a triangle that's standing up on your table. ABC would be considered a plane. Okay? And I was just looking at this, and I was wondering to myself, BDC, would that be considered a plane? I would think that that would be the same plane as ABC. Okay? Because they have, yes, this common line, but look at it like it's like a wall that goes something that goes through a sheet of paper. Name 3 points that are collinear. So 3 points that are all on the same line. Remember, we name our points by capital letters. All of those points are on this line here. Are the points A, B, C, and D coplanar? Well, I know A, B, and D make up a same line, and I know that that line, if I have 2 points or 3 points that are all collinear, they make up they're going to be all contained in the same plane. All I need is a third point that's not on that line, which is C. So yes, they are coplanar. How could I write that? I'm going to write it like this. How can I write my explanation is what I mean. Contains A, B, and D are in a plane by that theorem that we just talked about. And C A, and B make up a plane. Okay, point D. At what point, I'm going to do some erasing here so I can make sure I see everything. All right, at what point do DB and CA intersect? So line DB is this whole line, CA is this line, 2 lines intersect at a point, they intersect at point A. Part of geometry is also building figures, okay? So we are going to build a figure here, or drawing a figure, I should say. So draw and label a figure for the relationship. So plane R contains A, B, and DE, which intersect at point P. Add point C on plane R, so that is not collinear with A, B, or DE. So I have a plane. Typically a plane, we draw those as parallelograms. I don't know why, it's just what we do. And that's plane R. I have a line AB and DE. And D could be over here if you wanted. But those lines are going to intersect at point P. At a point on C, on plane R, I'm sorry, at a point C that is not collinear. So over off here to the side. Example 5, or I'm going to call this 4B because there's a little b sitting there. Draw and label a figure for the relationship. Q are in the coordinate plane, so you have to remember some of your algebra too in this geometry class. So Q is -2, 4. R is 4, -4. Ideally, I'd want you to use a straight edge on that. I don't have a straight edge here. It's hard for me when I am drawing this to draw with a straight edge. And I'll have rulers for you in the classroom. So those are that's my line. I labeled my points. Add point T so that T is collinear with these points. So any point that's on my line. So I tried to figure out what a slope might be. Ideally, you want to make sure that you have a straight edge. It looks like that point right there, T, is on the line. I guessed. Ideally, again, you would have a straight edge that you would use so that you would know exactly where the point, where another collinear point would be. Or if you don't know, you could put it, I just thought of this. There's my little marker guy, there's my marker. You could put it someplace that maybe it's not at an actual grid point, okay, if you didn't have a straight edge with you. But again, I'll have straight edges for you in the classroom. Okay, that was our first lesson, points, lines, and planes in geometry.